Thanks for joining me, Yogi. Much
Great to
appreciated.
be here again, Dan.
Yeah.
Looking forward to our discussion.
How has technology become the lowest risk aspect of IT projects? The complexity of what machines in general can do has greatly increased, but they've actually become so much better at what they do, and we've got so many more tools that can automate things for us. But our projects are getting bigger, more ambitious. The complexity of managing people, then we've got more and more sources of data. The complexity of systems, so integration. If we separate system integration from technology, I know from my own experiences that integrating different systems is one of the difficult parts of a lot of projects at the moment, especially as when we got our legacy systems and we're upgrading. Usually the legacy systems don't go away. We need them to be able to talk to the new systems over time. Or even if we are doing a migration, you've still got a certain infrastructure that remains in place when you bring the new technologies in, and integration is never easy. You usually discover things when you're doing the implementation that you didn't know about when you decided to take on this new piece of software, whatever it might be, which doesn't mean it was the wrong decision. It's just an extra complexity. Out of those different areas, people side of it, system integration, data quality, and the other non-technology aspects, which one has been coming up for you in your experience?
The list of topics you just described, Dan, are very much themes that increase the risk of systems implementation project. And you touched on integration. Integration is a huge problem because integration has to operate at multiple different levels. And there are semantic subtleties that get in the way of getting integration working properly. And no matter how brilliantly the team explains those to management is highly skeptical and sees that as just gold bricking, even when it's not, or lame excuses when they're not. That's a very difficult subject to talk about. And maybe we should talk about it at a subsequent podcast, Dan, because there are a whole lot of trends that have increased systems implementation risk. And you've touched on some of them. I thought today we're going to talk about how the technology has evolved to decrease the risk of IT projects and deal with those themes. And maybe we should circle back sometime and talk about those topics that you've already listed that have increased risk of not so much of software development, but of systems implementation. And those are not unique to IT projects. The one that comes to mind recently is the Crossrail underground rail system in London, England. Integration was the issue that caused billions of dollars of problem. And also the restoration of the Waldorf Astoria Hotel on Park Avenue in downtown Manhattan ran literally billions of dollars over budget, again, due to the kinds of risks that you just listed.
So let's pivot now to some of those positive developments. In your world, what have been some of the leaps forward?
Software testing and the use of AI in a sort of a overhaul or rejuvenation or upgrading of existing systems. And they're also valuable in greenfield new custom development work. For example, the use of AI to generate source code, not necessarily production quality, but something that will take a software developer 50-70% of the way there, and then they review that code, fix it up, fill in a few more blanks, and boom, they're ready for very serious testing. So that's emerging technology, looks incredibly promising. Now, you gave the example of using AI to examine existing code. You're going to look for two things. Do you really understand the functionality, even though you think you do? And are there software defects that have sat there for years? So again, AI has an opportunity to help software developers. So I'm hoping that those who choose to listen to this podcast will hear a number of themes and say, gee, we're not doing that. Maybe we should implement that some more. And software testing tools is one of those things that I invite people to examine if an additional investment in those tools will really help them. And it's part of a long list of improving software development tools. So for example, do you have an integrated development environment for writing, editing, compiling, debugging software? And if you don't, maybe you need to do that. Some software developers really like to use a command line interface. I think that's bad. A graphical user interface for software developer is much more powerful. And there's a variety of programming languages out there. There's a tendency to projects run amok in their programming language choices. I really resist that, because if different systems use different languages, your ability to reuse code and maintain the skills you need become serious problems and undermine quality and productivity. And it's not just about managing the source code, it's also about managing the data models that you have. So you need a tool for that. You can't just do that either with text or a CSV file or whatever other thing you're doing. I'm very big on using a more formal tool for that. And the same thing for managing your software modules and their versions and tracking the history and the evolution. That's really important for either understanding what enhancements are going to cost or rapidly identify and resolve software defects. One of the other advances that we've observed in recent years is the ability to quickly regenerate entire systems to correct misunderstandings in requirements or mistakes in data structures. You couldn't do that before. You tended to just put on workarounds, and that creates enormous maintenance problems when you engage in that kind of activity. So in addition to testing tools, I think all of these other tools help improve quality and software developer productivity. An organization hasn't made themselves use the full range of the tools I've listed. I invite them to have a look and see what they could add.
Can I ask, when you say to manage the data models, so I think a lot of, certainly I've just often used the various diagramming tools, like Visio, and there are certain ERD diagram tools out there. Is that what you're referring to, or are you referring to data management tools like, say, Calibra, Elation?
Good point. I was using Visio for data modeling activity as part of systems design is excellent, but somewhere along the line you have to move from the world of a logical data model, which using Visio can be very good. You have to go to the physical layer, and then you need a formal tool and maybe Calibra is one of them, to manage all of that data, the schemas, the valid values, and reinforce the naming conventions, understand the foreign keys, understand composite keys. It becomes very difficult to manage without a formal application in even a modestly sized enterprise. And too often it's seen as either superfluous or bureaucratic, and I don't agree.
Back a step to the higher level. So software development methods overall. So looking at the overall project, the project management, the specific roles, requirements modeling, what sort of improvements are you seeing in this area?
I'm very big on software development methods, and I think organizations tend to focus too much on the code. In my experience, a little more work upfront in detailing requirements and detailing designs before you hit the code, so to speak, pays off big time in quality and reduced elapsed time. But again, management often doesn't understand that activity is valuable and sees it as a bit superfluous as they observe it going on. And they think that real software development starts when somebody is coding. And I disagree. And I think it's a challenge for project managers and IT leadership to explain to management that, no, this is really valuable. And if you jump over requirements and design, you're going to be in the world of rework and rework and rework some more, as the real requirements pop out during acceptance testing, which is a very expensive way to do software development and leads to lots of unhappiness and even conflict in organizations. So back to your question about what tools support methods. Sometimes it can be as simply as doing mock-ups of screens using a graphics package as primitive as Paint or PowerPoint, and then taking a series of those screenshots and bringing them together to give a sense of the flow of the application, and that's a very simple but very effective way to do storyboarding. Now, so that's the screens. On the reporting side, Excel is a great tool for mocking up what you want the reports to look like and explaining how they're going to work. And that's dirt cheap and fast and malleable to run through many iterations to get it right. And you mentioned Visio. I think Visio is very good for business process modeling and for data modeling. In this day and age, there are some organizations that that understand there's value in in process modeling, but they ignore data modeling. In the 21st century, it seems like data modeling has become a bit of an afterthought for many organizations. And I think that creates huge problems when it comes time to enhance systems. When it has too primitive a data model, all of a sudden your enhancement costs that should maybe be $50,000 become $250,000 because your data model isn't accurate or doesn't accommodate enhancements very well.
I just want to ask, so with data modeling, we've now got a lot of data lakes that store unstructured data, but usually data modeling even now is really around the traditional relational model. Is that what you've seen?
Well, that's where it all started. And Dan, we've been doing decades of relational data modeling. I'm expecting in the next few years, we're going to see more and more data modeling around graph databases.
Right.
I'm expecting that the adoption of graph databases is already growing significantly, and that growth will continue. Now, I am not a fan of data lakes. Data lakes are a disaster. Now, I can understand why they exist. This is a way for the IT department to say, hey, we gave you access to all the data. Go away. You analyze it. We gave you some good tools. Get off our case. So I see data lakes just as a political technology that takes the backlog pressure off the IT department and pushes it onto the end users. That's horrible. I more want to give the IT department the budget they need to do a proper job of delivering the systems that the organization needs. Turning a bunch of end users who may or may not be good at SQL and who may or may not be very good at Power BI or some other visualization tool on this totally disorganized data lake where there's no usable joins of any kind, I think is an abomination.
Yeah, I've often found that well, in my limited world, that even though the data lake has the ability for unstructured data, and it's a great thing in meetings and conversations, you usually end up mostly using structured data in the data lake anyway. So you usually come back to relational database model.
Okay, so I understand why people want to get away from data warehouses, because they are really expensive to build and operate. So to me, the way forward is something that I'm sure you'll see in the literature called the data lake house. And what it does, it tries to be an in-between the totally unstructured, useless data lake and the completely structured, incredibly well-organized data warehouse that nobody can afford or wants to pay for or wait for. So in the data lakehouse concept, you start to structure and integrate the data sources as the requirements emerge and just focus on those integration points. And maybe you'll have to do some ETL as well to meet the requirements, but don't claim you're going to integrate all of that or structure all of that data. Just focus on what you need today or for the current project and pay, and the current project can pay for that and recognize the benefits of it. One of the problems with the data warehouse is there was really no owner, so nobody wanted to pay the multi-million-dollar bill for the thing. Whereas in the data lakehouse concept, each project has an owner and a budget, and will tackle structuring and organizing a small part of the data lake.
Okay. So I guess that's an example of reduced technology risk. So this idea has come up of the data lake house of an in-between, and so that's reduced. It's reduced the cost in terms of the risk because
It's reduced the cost of the data warehouse. It's produced a benefit in making data more integrated and available and accessible to the organization uh, at a price point that and a focus that the organization can choke down or afford or see a benefit of. The data lakehouse inherently has no benefit at all.
right.
Okay, we've put all the data together into this one giant unorganized pile. Nobody, you have to be a pretty senior developer, architect, designer to get some value from that.
This just rewinding briefly, but I just wanted to mention it with storyboarding. So just like you were saying, spending the time at the beginning of really drilling down into your requirements and making sure you understand those, and even using Excel, say, for the reporting outputs. So with storyboarding, though, of the screens and the mock-ups, the Gen AI tools are actually really good at doing that. You can explain what you want, and I know ChatGPT often, will say, "Do you want me to produce a graphical storyboard?" So,
Yeah,
storyboarding
great.
is, it's not something that it doesn't have to be a huge amount of work to create a storyboard. It's like, for a software person, it's like, I'm not creating a movie here or a theater play. But it's very much within reach. It's something that's quite easy to do now.
Agreed, Dan. I come from the world of simply doing it on a large sheet of paper on the side of a meeting room where 2 or 3 or 4 people can stand in front of it and use markers and collaborate on, well, what do you really want, and how do you want to flow from one screen to the next, and where are you expecting people to click, and what does an error condition look like, and get into all of those details. Once you've got a conceptual storyboard put together, and if AI, this text to graphic capability of AI can speed that up, great.
Graph databases. So yeah, there are a few coming up in the world where I am, which is in financial services. It's still relatively new, but you mentioned that you're seeing it as a big growth area. What are some of the applications and some of the benefits of graph databases?
The fundamental difference between a relational database that you access using SQL and a graph database is how the relationships among tables and the values in those tables are handled. As you know, in the world of relational, to create a relationship, you're doing a join, and that's how it works. Well, and in a graph database, you don't need to do joins because the relationships are physically there as pointers right in the database. And what that does is it dramatically improves the performance of queries, even large queries involving millions or even billions of rows. So one of the benefits of graph databases is that query performance is dramatically better than using SQL, particularly as the number of joins on the SQL side increases. Now you may say, well, if that's so wonderful, what's the downside? Well, the downside is that when you do an insert, you have to establish these relationships. So an insert in a graph database consumes more resources than the same insert into a relational table. So that's a downside. But it turns out that there are lots of applications where having these relationships immediately at hand are very useful. One of the prominent financial services examples is fraud detection. So the simplest example is when somebody swipes a credit card at a vendor in historic relational world, all we're really doing is checking about whether that card is valid. If it's a valid card, is the person overdrawn or not? Is it fake because the merchant code doesn't exist? So we just ask a very simple number of questions that we can determine right there within half a second or so, and the data is right at hand, and the application is tuned to performing those few checks and giving the merchant a yes, no very quickly. If you move that application to the world of a graph database, all of a sudden you can do some other checks, like what is the payment history of this customer? Have there been any other issues in the last month or the last year or the last decade? Because you have all of that history immediately available to you. You can still offer the customer and the merchant excellent performance, but you can do a much deeper check for fraud.
And because these capabilities are much easier to, faster to run, more efficient in a graph database, that reduces technology risk, because if you gave the task to a relational database developer to build an application that does this, it's going to take a lot longer. There'll be a lot more complexity. They'll need more computing power. If it's a cloud service, that's much more cost per transaction.
Yep. So you're right. The development cost of trying to do what I just explained in the in the verification of a transaction, it can of course be done in relational, but it would be hugely costly, which is why no bank has done it. They've accepted whatever risk there has been of not doing it. And that's one of the reasons why they have billions of dollars annually in write-offs. So there's a lot of thought going on in financial services around how we improve fraud detection and verification using graph databases. But again, in every organization, including financial services, there's this whole area of customer relationship management, CRM. We're interested to understand in financial services, which services is the customer using today? Which services might he or she be interested in? Which services don't we even want to offer because we think he's a semi-deadbeat? And when you try to bring all that together, all that data, those relationships become increasingly difficult to handle in relational databases. And I'm seeing financial services move in the direction of graph databases to do a more sophisticated analysis of their customer relationships. And that's not just financial services. That can work with any vendor who's selling anything, be it suits, be it cars, be it motorcycles, skidoos, ski boats. The list is endless. Every organization that sells something to consumers or businesses is trying to figure out how to do a better job serving their customer or selling their customer. And I'm expecting that as more and more data becomes available through digital transformation, that there'll be a gravitation towards graph databases because we want to make use of all that data.
Would you care to mention any vendors of graph databases? There's one that I'm familiar with. I think there are a number of, this will be our last point on graph databases. I understand there are a number of vendors who, they have graph database capability, but it's not natively graph. So it doesn't have the efficiency of graph. It does what graph does, and it makes it easy for the developer to do graph-like functions, but it's not natively built as a graph database.
So that's what happened as vendors say, customers are interested in graph databases. We can't develop an entire new product. Why don't we just put a graph veneer on our relational product? And that did happen, but I think we've moved beyond that now. So there's a series of products that are available in this space. Neo4j is one that comes up very frequently. There's Tiger. Amazon has an offering, so does Microsoft and Oracle. They've put a lot of development effort into improving those products, and there's work around standardizing the query language for graph databases because it's useful to have some verbs and operators that exploit capabilities of graph databases you don't need in relational SQL. So there's a bunch of work going on in that space.
So with these tools, just stepping back, so automated testing tools that can generate code, all the roles that we've always had of developer, business analyst, data analyst, DBA, tester. Can you see a time when a business analyst can be a tester because the tools to generate test cases and run the tests automatically are so good, or a BA, or at least a technical BA, can actually become a developer because they can generate code themselves? Can you see that happening, or would there always be a role for all of these kinds of skill in a project for different people who specialize?
Okay, so my experience is that these roles exist for a purpose. That different people have different personalities and different strengths and weaknesses. My experience is that superior software developers are very good operating in front of a screen and not so good operating in front of a bunch of people in a conference room. And business analysts are the reverse. They're very good at facilitating a discussion about requirements and design, and they don't want to spend all the day with their nose glued to a screen. So if you put the right personality into the right role, you're going to get a good result. On the other hand, I've seen this where organizations say, well, the software developers are sitting around while the business analysts are figuring things out. Why don't we have the software developers get involved in figuring things out? Very bad idea. What the software developers should be doing while the business analysts are thinking things out is thinking about how they're going to organize their development environment and how they're going to manage all the artifacts that they're going to be bringing. They should not be sitting around watching YouTube videos because there's no code to be generated. So to me, that problem is a failing of good project management. Either the BAs or the software developers are sitting around waiting for the other to complete their work. Sometimes some business analysts are very good at software testing. On the other hand, it can be very tedious if they don't like either. And other people, this is an interesting example of using autistic people very successfully in software development. They have the mental mindset that they can do software testing and not get bored by its repetitiveness. They actually are very good at doing that. And we've had some examples here in Alberta where there's a company that sprung up in software testing and some other tasks, deliberately using fairly high-functioning autistic people who would otherwise be viewed as disabled and be receiving some money from the government, and turn it around and give them a much better life and give them income and a sense of value and doing things that other people don't enjoy in the software development process. My answer is these roles have evolved or emerged in the last generation or so, and they continue to be valid, and certain personality types gravitate to one or another of these roles very successfully.
And that makes perfect sense. On the making sure that developers' time is being best used, if we're spending more time on requirements, if there isn't some other project that a developer is finishing off, so they're waiting to start on a new project, one thing I've seen is, well, bring the developer along to the requirements gathering meeting, which could be half a day or a day, because it's good for you to hear the thinking of the business people as well. So at least you know what's behind the requirements when you get the requirement, versus they may already know something about what is going to be created or what's going to be needed, but not in detail. So rather than having them sitting in a long requirements gathering workshop, they should be using what they do know, even if it's limited, to start thinking about how they're going to go about the coding when they get the detailed requirements.
I'm okay with software developers listening in on requirements discussion. I find they get bored very easily with debates. Mm-hmm. And they're saying, you guys are debating this. Why don't you just give me the answer? And I can run with the answer. They're just very impatient in that meeting. And the business analyst understands that there isn't an immediate answer. There's just a whole bunch of fog and a bunch of questions. And facilitation and knowledge of the business, you can synthesize a recommendation or the right answer from that. And it's probably going to take you a couple of hours, during which time the developer who's sitting in listening to this is either going to leave in frustration, grab a coffee, or is going to start watching YouTube videos on their phone, none of which are productive relative to what's going on in the meeting.
And on the facilitation part, it's clear that facilitation of a workshop to gather requirements and get the business people talking, that really is an art, because you may have you will have different personalities, different perspectives, and that's exactly what you have to bring together. And that is not easy. I just want to ask maybe a couple of an example of someone who's done that really well that you observed or that you've worked with. And also, do you think that all this virtual work is making that much more difficult? Because personally, I think it is. Having people in a room with a whiteboard is so different.
Okay, so this whole business of using video now for meetings, like every other technology, has its pluses and minuses. Before we had Zoom, we had no choice except to use a telephone, and a telephone is worse than Zoom. But you can't achieve on Zoom what you can achieve in a physical room with 3 or 4 people. You're not going to get the same result with 3 or 4 people on Zoom, because that interaction and the expression and the expert facilitation all have their limitations in a Zoom environment. And I'm not being critical of Zoom or Teams or what we're using here today, Google Meets. It's just the characteristics of the environment. And that the electronic whiteboard is a step of trying to simulate better what's going on in the physical meeting room. And it's a step in the right direction. Absolutely.
Facilitating requirements, that really takes a unique kind of mindset to be able to translate what one person is saying into the language that another person understands, and to find those connections. Like you might have a frontline customer service person explaining their problems, and then you've got an accountant explaining their problems relating to understanding the same information. But obviously one's coming at it from a people perspective because they deal with a customer.
And every one of those people you just listed, Dan, is actually just describing a subset of their issues and their processes. And it takes a skilled person, facilitator, to ask them questions to elucidate the rest of their requirements. Because if we just build to what they say, it's going to be an inadequate disaster.
So it's also noting what's not being said.
What's not being said is always more than what is being said. And that more is always what's needed. A very simple example is, okay, so here's the data elements on the customer master. Everybody nods their head and goes, yes. Okay, well, what changes occur here? For example, the customer changes his or her address. So is it good enough that we just type the new one over the old one and be done with it? Or do we need to track a history of addresses for a given customer? That has a huge, that single question has a huge impact on the data model and the complexity of the screens that we need for the system to be successful. And the same thing with a customer's name. When people get married and divorced, their names change. I'll give you a very simple example that it's become more important to have a consistent name everywhere. So I don't know what the rest of your name is. Are you Daniel? Are you Danny? Are you Dan? And if you have all versions of that in your relationships with governments and various vendors and the Department of Vehicle registrations and the passport, it's a zoo. And the systems somehow have to cope with the changes so I went through a need to synchronize all that because I had used various variations of nicknames and middle names and initials and whatnot. And as TSA started to become a real thing in the world of flying, that didn't work anymore. Even though it worked for decades, nobody cared.
That's just a great example of a non-technology risk.
It's a huge requirements risk, but it's not a technology risk. You're quite right.
Well, thank you, Yogi. I think we've covered a lot of aspects here. And it's clear that we've got a lot more options on the technology side, but the non-technology risks haven't gone away, and things have got...
And they have become bigger for the reasons that you mentioned. The systems have become more sophisticated, meaning more screens, more reports, more users, more integration points.
Thank you very much, Yogi.
Well, it's been great to chat. I hope this has been helpful. I've enjoyed our discussion, Dan.
Thanks a lot.